Hello and welcome to this specific contribution of this event, the contribution being the extent of a KNX stack according to AN 158. My name is Christophe Parthoens, by the way, and so I will try to explain to you how to convert a plain device, so device having no security or no encryption on board, to convert that into a device. Well, we call it a secure device. So a device being able to encrypt and decrypt telegrams. So let's have a look at the agenda or the overview. It's it's actually really short. So there's point one being a small disclaimer. I will, in the second bullet, I will talk a little bit about the manufacture tool. So because that's actually the first step in this in this process. And then I will talk about the actual stack extension. I will not show you source code because there's no point, I guess. I will just try to give you an overview, and that should really help you in that process, so that you at least have an overview, so that that you can plan your tasks in case you need to make this conversion. So the disclaimer is as follows. So the experience that I have, doing this job, is based on is because of KNX Virtual. KNX Virtual, as you may know or not know, is a Windows 10 PC application. So the environment is obviously a Windows machine, which means that I don't really have resource issues, so no limitations for me. I have I have I have everything, or let's say I have more than enough to my disposition there, so enough memory, CPU power, etc. So therefore I can unfortunately not really help you with this aspect of the task. So meaning I have really no idea how much memory you would need to add, how much CPU power, so to say, you need to add there in order to have this done properly. So unfortunately, I cannot help you here, but I can help you, of course, with the rest. Otherwise, this entire contribution to this event would of course not be very useful. So second thing is the manufacture tool. For that, I'm going to even give you a small demo. It's actually not even a demo. It's just to show you how things are done in manufacture tool. Basically, it just comes down to the following. So in the manufacture tool, you just need to open the application program that you need to convert, so to say. So you just select the application program and then have a look in its properties. So there you can see several entries for security. And basically, you just need to make the distinction between whether you're going to make a so-called coupler or what I tend to call a regular device. That's maybe not the correct term. Let me say that that you need to make the distinction between the coupler and a sensor or actuator, because then it's a little bit different. What is the difference? I have put it on the slide here. So first of all, for a coupler, or better said, for both the couplers and the sensors actuators, you need to enable the secure item. So that's right here. So this one. So I've set it here indeed to true. So by default it's set to false. You need to set it to true. So that you need to do in both cases. For the coupler, then you need to set, and also for sensors and actuators, you need to have set the individual address entries. So again, let's have a look. That's right here. So the Yeah, and the field is now, of course, not really visible, but if I click here, I hope you can see it. Yeah, okay, it's the one here where I'm just pointing. So security in individual address entries. That's what you need to specify. So yeah, for me it's very limited, only 5. So you need to put the number there, whatever you need, how big this table needs to be. Depends on yeah, your requirements, of course. And then for the rest, you need to make the distinction between either so for a coupler, you need to make a table, or have to say dimension the table of the proxy group key table. And for sensors actuators, that's the group key table. So let's go back. So that would be this here. So the first one. So because when I select it, then we have this thing that is blocking us from really seeing it. So the first one. So max security group key table entries, I've put there 50 hexadecimal. And if it would be a coupler, then you need to set this one. So the one that is in gray now selected. In this case, it's put to 0 because it's not a coupler. Yeah. And that's basically it. That's the only thing that you really actually need to do in the manufacture tool. So it's really not much. The actual work is, of course, in your actual stack, of course, and therefore I have prepared 2 more slides. Again, I will not really show you source code, just give you an overview of what you need to do here. So the first thing that you need to do is you need to take care of the telegram reception as such, because then in the, let's say, in the plain devices, it would be okay to have telegrams up to maximum 15 bytes in the payload, so which is expressed by the APDU, sorry. So for encrypted telegrams, it will be more than 15. So that's the first thing that you need to do. You need to make sure that, or in other words said, actually, you need to make sure that your device is able to handle extended frames. That's actually what I'm trying to say here. Then, of course, when you have that, second step in the process, so to say, in the workflow, is that you need to make the distinction between standard and extended. So that's first thing. And then within the 2 categories, you need to also distinguish plain from encrypted, because both in standard as in extended, you could see encrypted telegrams. In standard, it will be probably not very likely. It would be maybe a group value, right, with a 1-bit data point, let's say. Then this could happen, of course. But most of the encrypted telegrams you will find, most of the encrypted telegrams are, of course, extended telegrams. So how can you distinguish them? You just need to look for the APCI, so the very specific, the 03 F1 hexadecimal. Then you know that the telegram is an encrypted telegram. So obviously you need to decrypt that telegram. How do you do that? Well, you need to you need to use the tool key for that. So the tool key is the specific key for that device in order to decrypt the telegrams. Where is this key coming from? Well, initially it's the FDSK, the default key, if you want, which of course immediately, so right after the first handshake with ETS, ETS will override this FDSK by a secret key. And right after that first handshake with ETS, the device is supposed to use that secret key, of course, for any encryption that follows. Okay, so let's say we have the encrypted telegram now decrypted. Then what's next? Well, then you need to distinguish let me call it a data telegram from a synchronization telegram. A data telegram is what we will use for commissioning the device and, of course, for runtime. The synchronization telegrams are the telegrams actually, or is that specific category that takes care of sequence numbers, which is, of course, which is a protection against the man in the middle attack. So we don't have that distinction in the plain telegrams, by the way. So here, this is something that comes extra to it. So if we then look further into data and sync telegrams, well, then we see also a little bit of a distinction there, because in the synchronization category, we will never see, well, we'll never say never, of course, but until now, what is put in the specification, there are no multicast addresses there, so no group addresses for synchronization, which, of course, indeed is quite logical, I would say. So therefore, in data, we need to distinguish broadcast, multicast, unicast. I will give you an overview on the next slide. And within synchronization is then the two categories, broadcast and unicast, that we need to distinguish. So next slide. So if I look at data and then subcategory, if you want, broadcast, well then these telegrams are actually all about writing the individual address actually of the device, or reading it. So this is either done via the serial number or via the domain address. So depending on the medium type of your device, radio frequency or twisted pair, or even IP, of course. So that's data broadcast, data multicast. I'm going to skip that now. So I come back to it. First, maybe a few words on the data unicast. Because within data unicast, again, you need to make another additional distinction. That is, you need to distinguish connectionless from connection-oriented, because again, they are differently handled. Anyway, or whatever they do, the data unicasts telegrams are always, let's say, used in order to set memory, read memory, set properties, read properties, and so on and so on. Confirmed restart is also part of this category. So that's data unicast. Then a few more words on data multicast. So that's the runtime, of course. So the group telegrams. There again, you need to take into account a few aspects there. Also things that come extra in comparison to how plain devices in this context would be handled. So what is extra? I've put it here on the slide, by the way. So first thing is easy. If the telegram is encrypted and the group address that you find in that encrypted telegram, or decrypted telegram, of course, after decryption, that is, if that group address is indeed in the group key table of the device. So the group key table is not the tool key, because the tool key was the key that you would need for the device specifically in order to encrypt telegrams. Group key is just is the key specific for a group address of that device. So that's an important again distinction that you need to make. Well, anyway, if that group address that you found there is indeed in the group key and the telegram is encrypted, then of course you can process that telegram. But it could also be different because there are, let me call it, two exceptions there, and that of course could occur in your network. That is the situation where the telegram is encrypted, but the group address that you found in the telegram is not in the group key. Then obviously the device should not process this telegram. It should reject it, and vice versa is also true. When the telegram is plain, but you found out that the group address is in the group key table, then still you should conclude that something is wrong. This should not happen. So also here, don't process this telegram. And then to conclude, and because of completeness reasons, I will finish the slide here, and then it's over. Then I hope to have helped you here. So to conclude, so also in the synchronization context. So again, to repeat, so the telegrams that will help us, that will help you to protect your device against the man in the middle attacks. There you also need to distinguish broadcast from unicast, and also within unicast you need to distinguish again connectionless from connection oriented. Again, I'm really confident that this overview should help you. It should give you structure. Then, of course, it's still a big task to go within that in that structure, of course. But it really should help you. Well, that's it. Thank you very much for your attention.